Greetings students. Today students of class 8 will be talking about algebraic expressions and identities. Though we have discussed about it in class 7, this will be a quick recap before we begin or we get into the lesson, because here we will be learning about operations as well. So before we go to the operations, let us have a quick recap about what algebraic expressions are. Algebraic expressions have two symbols. We denote them by two symbols. One is the constant, another is the variable. Now, constant is any such symbol whose value doesn't change, and variable can be a symbol or a literal or an alphabet whose value keeps on changing. It's variable, as the name suggests. So if I write, suppose, let me give you an example, it will be clear. So the formula for the circumference of a circle is C is equal to 2 pi r, where C is the circumference, r is the radius, and pi is the pi value. So in this case, C and r, these two are variables, whereas 2 and pi, these two are constants, where the value of pi is 22 by 7, or can be called as 3.14. It keeps going on. So this is what the basic of algebra is about, how we denote it. But along with that, we also need to know that, we also need to know a few terms related to algebra. For example, I said a word term when a pair or a collection of this kind of constant and variable are written together. We call it an algebraic term. For example, if I write, suppose 7 as a constant and x square as a variable, so this entire thing becomes an algebraic term. Now suppose I have to write a long algebraic expression like 7x square plus 2 by 3xy plus 3y square x. This entire thing will be called as an algebraic expression, and each of these collection of constant and variables that are separated by the plus sign, which can be a negative sign also, either plus sign or minus sign, these individual terms are, as we call it, algebraic terms. Okay? Now, based on a few features, we divide the algebraic terms into certain categories. The categories are monomial. We divide the algebraic expressions into certain categories. So they are monomial, binomial, trinomial, multinomial. Now, what are these actually? The algebraic expression which will have only one algebraic term. For example, 2x. This is a monomial. There is only one group or collection of constant and variable, so it's a monomial. Then, if what is binomial? If there are two such terms like 2x minus 3y, as there are two such terms, so we call this kind of algebraic expression as binomial. So the name suggests trinomial means 2x minus 3y plus suppose 2 by 3 z. So as there are three such terms, it becomes trinomial. Then what is a multinomial which will have more than 3? So I can write it as 2x minus 3y plus 2 by 3z minus 3 by 4 xy. This is a multinomial. So in your chapter, these are the things that you have to figure out. There will be questions regarding this and you have to figure out where algebraic expressions will be given, and you will have to figure out whether it's monomial or binomial or multinomial or trinomial. Now there is another word, another term that you should know about. That term is polynomial. Now, why did I write it differently and not, as the name suggests, included with binomial, trinomial and all that? Well, because I wanted to emphasize on one part, that a binomial can be called as a polynomial, a trinomial can be called as a polynomial, a multinomial can also be called as a polynomial. You have to keep in mind one thing, that whatever the variable is, the variable's power should be a non-negative integer. Variable cannot be a negative integer there. If the variable's power is a negative integer, it is not a polynomial anymore. For example, 3 by 4y plus 2 by x. You can see, or you can say, that there are two terms, but in both cases y and x have the power minus 1. As it's a negative integer, we cannot call this example as a polynomial. Then what can be called as a polynomial? Well, all the examples that I had written previously about binomial, trinomial, multinomial, they can all be called as polynomial. Like 3 by 7 yz plus 2 by 3 xy. The value of the constant doesn't matter. The value of the constant doesn't matter. The order of the expression or the power of the variable needs to be positive. Okay? So that's about polynomial. One more thing which in today's class I'll be telling you is about coefficient. Coefficient, in very simple words, let me give you an example first. Let me write 3xyz, and let us consider z as a variable. Though x and y are also variable, let us put our focus on z. So in this case, all the variables or all the variable and constant together which are being multiplied with this variable of ours, z, these are called the coefficient of z. Okay? If I write the same thing, 3xyz, and if I consider y, then the coefficient of y will be 3x z. Okay, this 3xz will be coefficient of 1. So let me quickly count what we did till now. We did about what are constants and variables, what are monomials, binomials, trinomials. We talked about polynomials and we talked about coefficient. All this knowledge will be needed for you to operate on algebraic expressions. That's what we were aiming at today. So we will begin with addition. Addition of algebraic expressions. In your syllabus, you will have to add binomials, you will have to add trinomials, you will have to add multinomials. The first and foremost rule of addition is only like terms can be added. See, this is one more term that we need to know. Only like terms can be added. That means the algebraic terms with the same variables can be added. I can never add 3x with 3y. No one can. I cannot add 3xy with 3yz. So the variables need to be same. I can add 2y with this 3y. Okay? So the variable needs to be same. So what do we do if the variables are same and if we are adding something? Let me begin by a monomial. Very simple one. Let me write the example that I have given. 2y plus 3y. So here the variables are same, isn't it? So 2y can be written as 1y, 2y. 2y basically means this. 2 y's added together. What does 3y mean? 3y's, y plus y plus y. So how many y's? 5 y's. Right? So what did I do here? If I overlook this step, what did I actually do here? I added 2 and 3 and kept the coefficient and kept the variable the same. So that's what we do in case of addition. We add the numerical value, the constant, and keep the variable the same in answer. Okay? Now I will do a quick jump or a long leap. I'll take a long leap to a polynomial addition. Let's see how we can cope up with it. Let us think about an addition. Okay, let us talk about this addition. 7xy plus 5yz minus 3zx. This is an algebraic expression. Let us add 4yz plus 9zx minus 4y to it. Okay? So what should we do now? The first thing that we will do is we will remove the brackets. Okay? Before we start doing it, let me tell you, as you are just being introduced to addition, so there are two methods to be followed. One is this horizontal method that I'm telling you now, and next I'll be telling you about the column method. So I'll be telling you both the methods. You are free to adopt any method that you feel you are comfortable with. So let us begin this. In this horizontal method, what we do first is we remove the brackets. So let us start. If this algebraic expression is not going to change at all, we'll write 7xy plus 5yz minus 3zx. As there is a plus sign before the bracket, so there won't be any change either on this side. We will write it as plus 4yz plus 9zx minus 4y. The next thing that we have to do is group similar, or as I told you earlier, like terms together. Let us fetch out the like terms. This is xy. Do you see any xy? There are no xy's, so there is no need to change the position of any other algebraic term. 7xy remains solo here. Then is 5yz. Do you see any other yz? Yes, there is this 4yz. So we write plus 5yz and then plus 4yz. We also have 2zx. So we write them together, minus 3zx plus 9zx, and y is the solitary one, so we write it as it is at last, minus 4. There is nothing to be operated on this, so we write it as it is, 7xy. This 5yz plus 4yz becomes plus 9yz minus 3zx plus 9zx becomes plus 6zx minus 4y. So by horizontal method, this is our answer. So the basic thing that we did here is we grouped the like terms together, isn't it? Same thing we do in case of column method also. We just write it in form of columns. So this is the horizontal method. I'll show you the column method next with the same sign. So let me erase this, and now we move to the column method. We write down 7xy. Okay. Then we write down 5yz. As this 4yz is a like term to this, only the like terms can be written one below the other. So we do that here. Then we write down minus 3zx. So this first line is my first expression complete. Then minus 9zx is the like term to this, so we write down 9zx. Now, as there was no like term to 7xy, I left this place beneath 7xy empty, and now I am going to write minus 4y and make the lower or the later expression complete. But as there is no like term to minus 4y, so I keep the place above it empty. So now we operate on it just like we used to do in our previous classes, in our younger classes. 7xy is written as it is, plus 5yz plus 4yz becomes plus 9yz. We know if there are two different kind of signs, then we subtract and the sign of the larger term is adopted for the answer. We get 6zx, and here again no operation, so minus 4. If you tally it with the previous answer, you will find that the answers are same. So this is the column method. Okay, so I hope whatever we did today is clear to you. After this, we will go to the exercises to solve them. Okay, so that's it for today. Thank you everyone.